Okay, so today we are looking at area, and the first formula we're going to look at is for a rectangle. So the formula for the area of a rectangle is length times width. The L represents length, the W represents width. So if we have an example here, we have a rectangle. These two sides are the same, and these two sides are the same. And we have 14 meters, and we have 5 meters. So just using substitution, we're going to substitute those values into length and width. Our length is 14, and our width is 5. All right, make sure you use brackets to show that you are multiplying. And 14 times 5, that will give you 70 meters squared. All right, when we look at a square, all 4 sides are the same in a square, and the formula for the area is side squared, or side times side. Okay, so if we looked at a diagram here of a square, all 4 sides are the same, and if we have 8.3 centimeters, then in our formula, when we substitute that in, it would be 8.3 squared. Okay, now remember, when you have an exponent or power, it means 8.3 times 8.3. It's not 8.3 times 2. It's 8.3 times 8.3, and that gives an area of 68.89 centimeters squared. All right, and after the square is the rhombus. So recall that the rhombus it's a tilted square. Okay, well, let me write the formula first. The formula for it is AB. And when we look at it like this, we have the height, which is represented by A. So you can think of it like altitude. So in this case, let's say it's 10 meters, and all 4 sides are the same. And in the case of the rhombus, it's used as lowercase b, which represents base. So it's altitude or height multiplied by the base. So area is equal to 10 times 2, which is, oh wait, this was a 12, so 10 times 12, so 120 meters squared. All right, so one other thing I wanted to mention was whenever we have area, because it's a unit times a unit, meters times meters, that's why it's meters squared, centimeters times centimeters, so centimeters squared, meters times meters, so meters squared. So our units for area will have the units squared. Okay, parallelogram. So the formula for a parallelogram is area equals AB. A represents, again, altitude, which is the height. B is the base. Lowercase b is always base. All right, so there's our tilted rectangle called a parallelogram. And let's say we have 8 decimeters there. These 2 sides are the same, and those 2 sides are the same. And we have 27 meters here. All right, so in the rhombus and the parallelogram, it's important that you're using altitude or height. It is not length times width. The height is important here. So in this one, our altitude is 8 and the base is 27, and we'll multiply those together to give us 216 meters squared. All right, so triangles are next, and there are 3 formulas that you may have seen to calculate the area. So the 3 formulas for a triangle, A equals 0.5, AB, and you may have seen it as B and H, base times height. Still the same thing. A here is representing altitude, which is the height. You may have seen it as this, half AB, and again, same thing, half base times height, or you may have seen it as A equals AB divided by 2. All right, they all mean the same thing. They're all the same formula. 0.5 times AB is the same thing here. Half is 0.5 multiplied by AB, or you can take the AB, multiply it, and then divide it by 2. Same formulas. You can use whichever one you choose. So let's take a look at our first example for triangles. So let's say we have a triangle like this, and we have our altitude, and we have our base. All right, so I'm just going to use the first formula here. So area equals 0.5 times A times B. So 0.5, the altitude is 7, and the base is 16. All right, so you just have to multiply 0.5 times 7 times 16. Put it into your calculator, and we get 56 meters squared. So if you used this formula or this one, you would still end up getting 56 meters squared. And after triangles is trapezoids, and there are two formulas I'm going to show you for trapezoid as well. Trapezoid has two formulas that you can use. The first one is area equals 0.5 multiplied by AB1 plus 0.5 multiplied by AB2. So B1 represents base 1 and B2 represents base 2. The other formula, which I find is a little bit simpler, is 0.5A, and then in brackets we have base 1 plus base 2. All right, and recall that a trapezoid looks something like this, usually something like this. It is a four-sided figure, and these two sides are parallel, meaning they're equidistant from each other. All right, so you would call one of them base 1, the other one would be base 2. And A represents altitude. So in this case, let's say we have a 7 centimeter there. We have the base, and we have another base. All right, so base 1 we could say is 16 centimeters, and base 2 is 12 centimeters. The bases are always the two parallel sides. All right, and then the height is here. Now, sometimes with questions with trapezoids, sometimes you're given extra information, like they might give you a side here or a side here. But remember, we don't need those when we are calculating the area of a trapezoid. You need the altitude and you need the two bases. All right, so let's try this question. All right, so I'm going to use the first formula, which is area equals 0.5 AB1 plus 0.5 AB2, and now I'm going to substitute. So area equals 0.5 multiplied by A, which is 7, base 1 is 16, plus 0.5, altitude is still 7, and then base 2 is 12. All right, so using BEDMAS, make sure you multiply this and multiply this out, and then add them together. So area here 0.5 times 7 times 16, that is 56, plus 0.5 times 7 times 12, that is 42. Then we add those together to give 98 centimeters squared. All right, so that was using formula 1. And now let's do it using formula or method 2, which is area equals 0.5a base 1 plus base 2. All right, so substituting my values, the altitude is 7, and then base 1 is 16, base 2 is 12. We'll add in the brackets first. So 0.5 times 7, 16 plus 12 is 28. All right, so now all we have to do is multiply 0.5 times 7 times 28, which is the same answer as before, 98 centimeters squared. All right, so same answers both ways. So you can choose which formula you want to use. This was the first formula, and that's the second formula for trapezoids.